everyone. Hello, members of the CSI BIM practice group. This is Roger Grant. I'm one of the leaders of the practice group. Thank you for joining us. This is our CSI BIM practice group meeting for April 20, 2012. Today we have an interesting agenda continuing on the theme we've been following around integrating building information modeling and specifications. We'll be getting started with a little overview here, and then we'll be hearing from Brian Payne about his work with BIM and specifications, but more on that in just a minute. So I'm joined today by another leader of the practice group, Beth Stroshane. Beth, are you there?
I'm here. Okay.
And those of you who've joined us the last few months have heard from Beth a few times, so you know that she's a good monitor for this session. She's been speaking with us about BIM and specifications, and we're really continuing that theme about how to work with specification and authoring software and building information modeling tools. Well, so we're going to move on then and introduce Brian. Brian is an architect, and as Beth mentioned, he works for BBH Design, a smaller firm in North Carolina. Brian, I'm going to go ahead and turn the presentation over to you.
Thank you. Well, again, like Rob introduced, my name is Brian Payne. I'm an architect with BBH Design, and so since this is called a small firm's perspective, I thought I'd give a quick little information about us, most of which you've heard. I work for BBH Design as our specification and BIM lead. And so we're about 65 employees in 2 offices, one in Research Triangle Park, which is next to Raleigh, and another one in Charlotte, North Carolina. And so we're not really small firm. We've been using eSPECS and Revit. We kind of started when we were about 50 people, so fortunately we've grown a bit. But we are implementing this across 2 smaller offices, and we've been using Revit now for about 4 years, eSPECS for about 1.5 to 2 years, and really starting to kind of tackle this integration process for about the last year. And it's been a fun journey, it's been a hard journey, and hopefully you guys will be able to pull some tips and understanding of kind of what our process looked like, and maybe learn from some of the things that we've gone through. So today I quickly want to kind of go over an overview of eSpec for Revit, what that process looks like, what that integration between Revit and eSpecs looks like. We're going to go over some tips. We're going to look at 3 key components of a successful transition, at least from my opinion, and that's your Revit content, your assembly codes, and the Office Master Specification aspect of the process. Also going to go over some additional tools and tips. Okay, so the overview of eSpecs for Revit process. We currently do the majority of our projects, I'd say 95% in Revit. And so when it comes to specifications, we're usually starting off with a schematic design or design development model. For those that know Revit, know this little building well. It's the sample project. Each project is made up of building components. Here we have a single door, wood door with hollow metal frame. When you select that component in Revit, it brings up the type properties dialog box. And this is kind of the first location where you really start integrating with specification, and that is by assigning assembly code. And so if you look right here, you can see that we have an assembly code that's being designated to this, this family type. That assembly code is being pulled from this dialog box here, And this file here, this assembly code file, is a master file that each company creates. Let's see, let's get my highlighter. Each one of those assembly codes is controlled by a Uniformat classification text file. And this text file is the key link that joins your Revit model with your eSpec program. And so, as you can see on the left, we have our assembly code list, and in the small box on the right, in the binding manager, that same list is there, and that file is the file that's really connecting the two and communicating between the two programs, between your model and between the writing of the specification. If we take a closer look at what that eSpECS binding manager has, you'll see on the left here those assembly codes, and specifically the one for, let's see, specifically we have the one here that for that single door that we were looking at. On the right, you can see the bindings that this is connected to. These are paragraphs or multiple paragraphs in your specification that's being connected to. And as if you've been listening to some of the other lectures by Beth and others, you'll kind of be familiar with some of this. And this is eSpec's way of really having that close connection between your model and your spec sections, done by this kind of checklist system. Oops. That checklist dialog box specifically controls individual spec sections. And so what it does is it takes multiple assembly codes that are changing individual checkboxes and works and combines all of that input from all of the different families in your project and gives you a dialog, the section checklist box here, that directly controls what shows up in your final specification. Now, you're not done. This is getting the majority of your content, and I've heard conversations in different forums in different places where people have seen anywhere between 50, maybe on the low side, to 70% of your specifications completed through this process. Let me get back to where I was. So through this process, you are generating the bulk majority of your specification. The last bit is the fine detailing that you would do and the custom content from a project-specific kind of viewpoint. So quickly, what are the tips that we have kind of coming out of this process? I listed 4 here, and some of them seem obvious, but they can be really important. The first one I'd like to say is set a series of small, realistic deadlines and stick with them. This whole process can be really overwhelming. There's a lot of content, there's a lot of specification sections, you have different kinds of projects, and one of the challenges is kind of planning out how are you going to tackle this transition between maybe a traditional way of writing specifications and this new integrated approach. And so one of the tips that kind of came out of our process was, stick to small deadlines and small goals that you can reach to help keep that momentum going. And that's true in a lot of different transitions and times of change. But specifically in this case, I don't think you want to approach this process thinking you have to do everything. Your goal may be just to start using eSPECS for the first couple months without any process and getting used to the program. And then kind of build up from there as you go. It may start on a small project, an individual project, and then move to a larger project. So there's a lot of different ways you can kind of break up your transition where it's not like a flip of the switch. The second point is kind of based on that as well, is commit to transitioning by individual model category, specifically talking about Revit here, if the whole model seems daunting. The image you have to your right is the typical breakup of Revit content. And so one thing you could do is just take your walls and doors, for instance, and let Revit kind of generate a specification with eSPECS just in your walls and doors to start with. And you might learn through that process and approach your other sections maybe slightly differently. There are things on this list, for instance, detail items, that we plan on implementing, but we have not yet. And just because to do everything at once, like I said, is a lot of work. And so that would be my second tip, is take it in chunks if you have to. Third, different specification sections will require different levels of integration. I think one of the challenges is communicating to your team, your implementation team, and to your project teams which section requires what information. For instance, you might have a specification section that's termite control. Well, there's not much you have to do on a section like that. There's not a lot of integration probably. Whereas if you had a interior partition family that has all kinds of components in it and fire ratings and lead lining for healthcare projects, those may take a longer level or a deeper level of integration than just pulling your termite spec section. So the third tip really is to approach each spec section differently and figure out what do you need that section to do for you, what is worth the effort for the payback coming back. And we'll get in later to some of the details of what that looks like. Fourth is, might be a little obvious, but it's continually invest into your template, your Office template. One of the things that's really easy to do is to make a project work really well, integrate the integration of a project and all the content in that project. But unfortunately, if you don't get that back into your template, your next project, you're going to have to rework that effort. And so we saw that on some of our early projects as well. And so you really kind of have to keep a mindset of anything I might do in a project that I want to keep, I also have to do in my template at the same time. And that's a level of effort and a level of work that, if unplanned for, might be challenging. And so that's something that we saw on our project teams, just making sure that there was that feedback into our template from lessons that they learned. Is there any questions that we have?
So the first question that we've got, and I can answer part of it, but I'm going to let you take the first crack at it, is that it appears that the linking together is a similar workflow for Linkman without using that program. Is it available in eSPECS without additional software? So maybe this would be a good time to talk about the different pieces of software that comes with eSPECS. Yeah, eSPECS has several parts. You have the eSPEC software that specifically just writes the specification, and that's eSPECS for Revit, which can be kind of confusing, we found in our own firm here, because people think necessarily that means you have to have an integrated process, and it doesn't. But eSPECS for Revit is the software that we use to edit just our regular specification sections. The key piece of software that you need to install into Revit is a eSPECS console. And this console is an add-in, and I have a slide farther on that we'll get to that kind of shows that. But this console is what can really help the communication between eSPECS and Revit. And it's the software that pushes the information between the models, between the model and the specification.
And then also upstream, one more is eSPECS Designer. Is that still a separate piece of software?
Yeah, and again, we'll hit that a little bit later on as well in the presentation. Okay. But just to give a quick intro, eSPECS Designer is the Office Master editing software that is used, and as you'll see later in the presentation, it's an integral part to this process.
Okay, perfect. The next question is Uniformat classification.txt is a file that you have, or is this file something you have added that goes into greater detail than the out-of-the-box Revit file, and does eSPECS come with a more detailed version?
We actually will be answering that question in a little bit.
Okay, perfect.
So it's a great question, and it's part of this webinar.
Okay. When you described letting eSPECS generate a spec section, where does that section come from? And what about linking assemblies to manual spec sections, such as Word files that came from a manufacturer?
Yes, eSPECS Designer comes, or eSPECS itself comes with Master Spec and a couple other specification files. And so personally what we do is we take Master Spec section and we tweak it for our own Office Master. And so it's what we're working with here is a version of Master Spec 3-part CSI section for all of our spec sections. You can bring in outside text files or linking in documents that are other specification sections into eSPECS through eSPECS Designer. And that allows you to assign an assembly code to that spec section. So yes, you can use manufacturer spec sections within this process.
Alrighty, and that is the end of the technical questions.
Okay. So the next thing that I wanted to kind of go over is what are those kind of 3 areas, and we kind of, some of the questions hinted at these. What are the 3 areas that are really key? And in my opinion, it's having almost like 3 legs of a stool. You need equal quality in your BIM content, your assembly codes, and for lack of a better term, your Office Master specification, and we'll get into what that means. And part of this transition that we had to take involved coming up with what our implementation team is going to be. And so you can see the questions kind of around these 3 key aspects. For the BIM content, who is building the quality of BIM content? You know, out-of-the-box content can only take you so far in this process, since this is become such a customized individual fingerprint kind of solution. Who is writing and revising the specifications? And that's not only just the implementation period or your big kind of kickoff push, but that's also the question that you have to ask yourself during the process. Who is assigning and creating assembly codes? How this implementation team works together is one of the key kind of solutions that you have to understand as you start your process. If all 3 of these is in the same person, and in my case it has been here, then this process looks very different than if your master spec writer doesn't know how to use Revit and isn't the person assigning assembly codes on the project team. If all of those are different people in a small firm, then, or a large firm for that case, then the process is going to look differently. And so we don't really have time to go through what those solutions would be or how that would look in each situation, but just kind of want to make everyone aware that that's actually one of the biggest challenges, is kind of understanding what that team dynamic is going to be and what that process is. The reason there's arrows here is that the specs feed into the content tells you kind of how you want to write your specs, the assembly codes changes how you do your content,
everything kind of influences each other, and that's why not for the whole model, but at least for each chunk that you take on, each three parts kind of has to grow up equally as you implement this process. So BIM content specifically, out-of-the-box content. It comes with a lot of challenges. A lot of this content hasn't changed since Revit 4 or 5, maybe even Revit version 1. It doesn't have a lot of the things in there and technical kind of ability that a lot of custom content can have. I just listed 3 examples here on the left, and the first 2 of these examples we'll see specifically in the next slide, but type parameters versus instance parameters. That changes how you work with eSPECS, is whether parameters, for instance, in a door, as we'll see in the next slide, if those parameters are type-based parameters or instance-based parameters, that really changes kind of how you approach your assembly codes and how you approach generating specifications. Nested components is another aspect of custom content that can impact how you do things. An example of this might be a fire extinguisher that's nested inside of a fire extinguisher cabinet. If you had a situation like that, the fire extinguisher could have an assembly code and the cabinet. If your content is a fire extinguisher cabinet that doesn't have a fire extinguisher in it, for example, then your assembly code is going to look a little different because you're going to need to combine those 2 spec sections into one assembly code. And so how you build your content affects what your downstream decision process is going to be. And so the question on the bottom is your BIM content consistent, flexible, efficient, lightweight, and accurate? All of those things are important for modeling in Revit, but as soon as you add in eSPECS, it now becomes important for how you kind of forecast and plan your future content and the assembly codes and how everything is kind of bound together, as we'll see in this next slide. So here's a simple door to give everybody kind of a real-world example. You see in the right-hand corner we have an assembly code up here. We have an interior wood door and hollow metal frame glaze is the description of that assembly code. On the left down here under type parameters, the ones that are highlighted on your screen are the ones that come out of the box with Revit. Mainly the out-of-the-box door in Revit only controls some of the dimensional characteristics of the family. But this list of type parameters is what our custom content here is actually controlling. It's an interior door with a vision panel. It's a type 1 frame. It's a hollow metal frame. The door is a wood door, and then it's 3 by 7 and 1 3/4 inch thick. It has a certain frame head width, which in this case is 2 inches, and it has a fire rating. In this case, it's not applicable, but that parameter exists. And so by assigning this assembly code specifically to this door, these are the specification sections that we have connected to it. Not just the section, but a lot of detailed information in it, as we'll see in a little bit. It's pulling the hollow metal door and frame section. It's pulling the wood door section, the glazing section to coordinate the glass on the door. It's pulling in the door hardware section. Maybe not a lot of information in that section. This is one of those situations where it might just be pulling the section in and it's still manually edited. And it's pulling the interior painting section in because we can, to be honest with you. There's no reason you can't start tying some of these smaller sections to something. If you know, for instance, that this hollow metal frame is going to get painted, then you can tell your paint section that your paint substrate is going to be, steel. And so that's a kind of a small connection that you can make. You also have everything from manufacturers that you can connect you can dig down as deep as you really want to with eSPECS. And you can also, because we know these 5 sections are coming in with this one assembly code, you can actually pre-select related sections, so that only the related sections that show up in the specs are the ones that are being generated, in this case, from this door.
And I wanted to add one thing to that slide that I think is super cool, is because he's linked these sections to that assembly code, people within Revit modeling, when they click on that door and they say show specifications, you will see all of those specifications from within Revit.
Absolutely, absolutely. And that tool, the ability to instantly pull up a spec section by clicking on the Revit content, is something that we've been using here. And going back to kind of my introductory statement about like what does this integrated approach look like, that's one of the key aspects of that integration is, you know, why do we want this connection? Why do we want to be able to have your spec generated? It's not purely a time-saving element. It's a collaborative, integrated process that allows the kind of ebb and flow of specifications and building content to simultaneously go down the same path. So that as your door is deleted from your project, so are these aspects of these sections that this door is you know, causing to show up. One of the questions earlier that we had was specifically on Uniformat, and the person that asked the question is correct. Revit comes out of the box with Uniformat 2 codes, and unfortunately they're very vague. It takes you down to a level 3 category, which in our example on the bottom here, I'll take my highlighter out. In the example, that's pretty much as far as level 3 takes you, is you have an interior door. Well, that interior, you have lots of interior doors, and interior doors pull lots of different spec sections, as we just saw on the previous slide. And so one of the challenges is having to create a lot of subcategories, each firm having to do that themselves. And so one of the things that I found, and this honestly just came by Googling it, is that I found the Uniformat 2010 kind of categories. And Uniformat 2010, as it says here, describes building elements, but specifically it takes you down to level 4 categories. And as you can see below, C1030.10 is interior swinging doors. And that's a much kind of closer to the final result description that we want. If we go back a slide, if we go back to the slide, you can see that we took that same C1030.10 and just added the final level 5 code to it to be specifically an interior wood door and a hollow metal frame swinging door. And so that's the process that we took in order to kind of build our assembly codes, is by starting off with the Uniformat 2010, we had a much more robust categories in order to tweak to make work for us. So what content becomes an issue assigning assembly codes? Well, there's a lot of things in Revit that you don't model, and we primarily assign assembly codes to modeled elements. You can assign them to detail components, but we really haven't gone down that path so far. That's kind of one of those chunks that we're going to tackle. Fire-resistive joints, wall base, paint, cavity insulation, these are elements in Revit that are traditionally not modeled. Thus, you can assign assembly code. And so the question on the bottom here is, what is the trigger content for your specifications? If your specs are being generated by your content, you know, figuring out what triggers individual paragraphs, individual sentences, or entire spec sections is one of the key things that you have to do. Complicated assemblies is another complicated area that if you have an exterior wall
that exterior wall may have 10 different components in there, and writing an assembly code for that is almost just as much work sometimes as than just, picking the components out or the spec sections out yourself. And so you kind of have to judge each area and figure out what is the most efficient way of getting your end result. The other thing that Uniformat specifically causes issues with is that they separate everything from interior and shell. And when you have, for instance, a automatic entrance door, you might have one both on the exterior and on the inside for like a vestibule, where you have two of them, or you might just have an interior one. And some of those elements you end up having to duplicate just so that you can appropriately put it in either the interior section or the shell section, or kind of find a home for it. And so not all elements can be split up between exterior or interior and shell, and so that does make it a little bit more difficult when assigning assembly code. So here's an example of a wall that we have, an assembly code, and you can see that you have a couple different options for this wall. It might be fire rated, it might have sound attenuation, it might be lead line for healthcare, or have a different type of gypsum board. Let's say it's abuse resistant gypsum board. And so you have to kind of design your content in order to generate certain kind of specifications. And so there's a lot of effort that goes into building these assembly codes based on the way you specify products. In this example, we have 1, 2, 3, 4, 5, 6, 7, 8 metal stud and shaft wall partitions. And you can see here that we had to duplicate our assembly codes based on whether it had sound bat or rated, or if it's smoke partition, or it's a rated partition, smoke and rated. That's an example of how a simple partition may end up having to have multiple assembly codes depending upon what these little options are for it. And so kind of figuring out how to manage your assembly codes is important. One quick tip in this: most of this information, as far as manufacturers of gypsum board and things like that, most of that's being driven by metal stud gypsum board partition. We go on the 99% rule. If 99% of our projects or 95% of our projects contain a certain assembly, we might have that assembly do most of the legwork in order to drive the specification section. That way, the sound bat one might just pull sound bat. And that's a risk that you have to take if you kind of limit it. But in order for us to be able to manage this content without having a full-time person doing it, we kind of had to make those shortcuts where one assembly code does 99% of the work and the other ones kind of just fill in the blank and hit just a couple spots here and there to pull certain products or pull certain accessories.
Brian, it's Roger. Can I ask you a question?
Yeah.
Well, is it also an option to use your properties as opposed to making those separate specs or separate Uniformat sections? Why do you feel you have to make separate Uniformat sections below a certain level?
Below a certain level. What? Can you explain that a little bit more?
Well, for example, you have here the metal stud gypsum board partition, and you have a separate section for with soundboard. But couldn't that be treated as one of the properties?
Yeah, Revit does. I mean, eSPECS does allow you to use. In the bottom here, you'll see the parameters. It does allow you to assign parameters to it so that you can also go look for certain properties like a type comment that says lead line in order to pull certain ones. And we're starting to do that more. One of the challenges that we have is that you end up having a lot of different options. In this case, we had rating, sound bat, smoke, a lot of different aspects of it. And the effort it would take to manage those under parameters didn't seem much different than the effort to do it in the assembly code.
And in eSPECS, eSPECS has a validation report that allows you to kind of add those parameter values in. But we find that our teams are also responsible for adding assembly codes in. And they find the easiest way of doing that is just to pick a single assembly code and know exactly what they're going to get in the spec. And so because there's kind of that kind of raw connection between, hey, if I choose an assembly code and I know what I'm getting in the spec, it's easier to get the buy-in from our teams to assign assembly codes themselves and not have the spec writer have to be responsible for the entire assigning of all assembly codes. And
well, there was a follow-up question along these lines of how do you manage all those codes then?
Yeah, right now we have myself actually is the person that manages those codes, and it's a way to provide oversight for our other people that are writing specification sections. If I find out a manufacturer that I might want to use or not want to use, if I change that in my codes, then when the spec is automatically generated from anybody, then that is updated across the board. And so there's a bit of kind of oversight in the specification process that you can provide as an assembly code writer. And so if you think back to that slide that I was asking, who's writing codes, who's writing assembly codes, that's one of those planning processes that you really have to go through in order to understand what is that dynamic relationship going to look like between the person that's making these decisions and the person that's writing the specification if it's not the same person.
Yeah, you could have some challenges to avoid duplication if you have multiple people doing that.
Absolutely. And so that's one of those things, and depending upon where the expertise in the office is and where the effort and the time to do this is, it does take, it does take an effort, and it definitely takes a plan to accomplish. So the last portion I wanted to get to is the Office Master Specification, and I kind of just copied from eSPECS how they described their program. It enables firms to customize the existing intelligent masters integrated into eSPECS to suit their design firm's preferences, as well as integrate their own custom Office Master Sections. The major point, as I wrote on the bottom here, is, in my opinion, eSPECS Designer is absolutely critical to producing quality specifications through this integrated process with Revit and eSPECS for Revit. And the main reason is that Master Spec controls the bindings, the mappings that come between the checklist and the specification that's the result of those checklists. And unfortunately, they're not always done well. To be nice. And I'll give you an example. There's several specification sections that ask you if your lead requirement, if your materials want to be within 500 miles. And a lot of our projects are lead, and so you'll select that. And let's take, for instance, a unit masonry spec where you have, brick. We would say, hey, we want our brick to be within 500 miles, so we'd select that button. And unfortunately, that paragraph, that checkbox, is connected to the same paragraph under every product in unit masonry. So when you say that you want brick and it needs to be within 500-mile radius, you get clay masonry, you get CMU, you get everything else showing up in your specification because that mapping is not done in a way that really helps the process. eSPECS Designer is the program that you need to use to go in there and to tweak those mappings to show up exactly the way you want. There's examples in pretty much the majority of the specification sections that I have found that don't quite turn off every paragraph you would expect to. So you say that you don't want brass, elevator door, and the brass under materials is still there. Now the brass product, in section 2 might not be there, but you might find something in execution that shows up. And so there's always these little moments that you need to go back to and tweak. The other limitation that I wrote here
is when you're working with multiple types of the same product. Let's go back to, let's say, decorative CMU. You might have 2 decorative CMUs, but eSPECS bindings are only set up to control one kind of instance of decorative CMU. And so if you want a family to generate split face and another family to generate a different kind of decorative CMU, then you can't do both of those at the same time. And so that's one limitation without really going in and rewriting the section. And so that can get frustrating sometimes if you use a lot of different versions of the same product. Here's an example of what Designer looks like. I won't go into this too much, and it's PowerPoint, so I can't really show you guys what this looks like right now. But as you can see, the words in green on the right are those mappings to the checkboxes on the left. And so as you check on and off certain things, certain paragraphs show up. And it's these green mappings that are really crucial to make sure that are working exactly the way you want them to work. That's why I believe that Designer is integral to the process. If you didn't have Designer, then you wouldn't be able to manually tweak these in order to get the exact specification that you would want. Some additional tools I wanted to go over the last couple moments here. Some of these this was brought up in the questions before, but the most important one is the eSpec section viewer. And this is Revit Console. This is what shows up inside Revit under add-ins. This is kind of what communicates between the 2 programs. And you can bring up any spec section that's been assigned through an assembly code to an element in the model. In this case, we have a toilet bath accessory. And it allows the teams to be able to mark up the spec section while in Revit. And those markups show up the next time that the spec writer opens up eSPECS. This has become absolutely crucial part of our process now, and it's something that we're really excited about. We can get that integration that we're looking for as a firm into this process through this tool so much better than we could before. We can, send notes. We can describe products. We can cross out, sections that we don't need, all through the use of this. Some of the other things that this console does is allows you to run reports. You have table of contents, because I can't tell you how many times I have someone coming up to me in the middle of the day asking me what spec section something goes into. So, there's a table of contents there for them to be able to pull up that is up to date with what the spec writer is doing. You have a submittals report that just pulls what submittals your specs are asking for. This is something that we're using and coordinating with our CA department in order to make sure that they understand what their responsibilities in the field are going to be based upon what's in our spec section. And without having to flip through 1,000 pages, they can get a quick summary of every submittal that's going to be coming across their desks. And an executive summary is just a report on mainly the products that you're speccing. Great for PMs and PAs to get a quick glance at what's in their project. And then eSPECS does have a keynoting tool, which we haven't implemented yet, but it was worth noting here, even though we're not using it. So lastly, I just kind of wanted to throw out a couple tips. BIM content. Plan for the future when designing your content. Try to make it as flexible as possible, even if you don't plan on using it in a certain way. Designing it in such a way that allows that flexibility in the future is a great idea. And it could just be as simple as, making sure that you have a parameter in there that you need in the future, or that it's just consistently drawn so that you can pull the right information out. And this comes into play a lot with the object-based parameters versus the instance-based parameters. Assembly codes, get ownership from project teams to help maintain. Our culture kind of already had this idea that the project teams were responsible for the keynote and the naming convention of the family. Getting them to understand that the assembly code also was something really important to them wasn't the easiest thing. That's a challenge to kind of get the teams to understand, because they don't have a daily interaction with that assembly code. So getting them to kind of take ownership of it is a key to a successful project. And then the Office Master Spec, especially if you have multiple people writing specifications. Creating some kind of feedback loop so that those paragraphs or those sentences that accidentally show up in your specs because the assembly code wasn't generating exactly the right format, or Master Spec didn't have the correct mapping. Having a feedback loop to get that back to the person that's in Designer and changing things on a day-to-day basis is key. It's really easy on a project level just to make it disappear. Unfortunately, the next project is going to have the same issue. And so we really want to see people taking that information and filtering that back to the person that's in Designer so that they can make that change for the last time, for the last project, and get that into the normal template, the Office Master template. That's all I had. So I'm free for questions, and hopefully we have some.
Yeah, about a dozen. So a sort of easy but good summary question is can you summarize how the integration has been beneficial in terms of quality or time savings?
I think the 70% of the spec being done the day you open the specification section has been something that we've seen. Obviously, there's, terminology and final finishes that you have to kind of coordinate with your teams. But we are seeing for, I won't say all spec sections, but the majority of the spec sections, at 60 to 70% of it is edited before we even have to open it up. And so that, from a kind of a time savings, is a real number. Now, I will say that 60 or 70% is being spent in Designer, finding all those little tweaks. It's being spent creating new assembly codes for future projects. And so right now, I wouldn't say that we're seeing a savings as much as we're reinvesting that time into future projects. If I was to answer that question a year from now, I would say that we are getting all of that, savings back. But hopefully that answers your question.
Okay. I kind of usually tell people that working with BIM, the first project is brutal. The second project, you're willing to do a third one, and by the third time, you're doing pretty well. Another question is...
Go ahead.
Go ahead.
I was going to add to that is that as soon as the more that you do projects through this integrated process with eSPECS, the better your eSPECS becomes. And so in the same way that it works in BIM that way, your content is continuously improving, your assembly codes are improving, and you start getting momentum behind you. The worst thing that we found that we can do is to go on a different path and go back to traditionally what we were doing, because it kind of brings the whole process to a stop. And so even though it might be taking us just as long, we're choosing to go down this path because we know it will pay off.
Okay, we've got one great suggestion that we'll probably talk to the group about and implement is having a separate presentation centered around discussing markups and dynamics and have lots of times for question and discussion. So that would probably be good, just having an hour for that where everyone can answer or ask a lot of questions and have everybody there to answer. Another question is please confirm that assembly codes and spec sections do not have a one-to-one relationship. A spec section can be turned on by many different assembly codes.
Yeah, it goes both ways, and I'm trying to think back to the door here. This one assembly code, C1030, is driving those 5 sections, but you might have 10 assembly codes that are driving hollow metal doors and frames that are all kind of choosing different aspects of hollow metal doors and frames. In this case, we don't have a hollow metal door, but we might have another door on the project that does have a hollow metal door, which is checking those boxes in that section. So yes, you are right. It's not a one-to-one relationship either direction.
Okay. What process do you go through when your Master Spec content is updated? When you get new stuff from Master Spec? And how that incorporated into your eSPECS specification?
Anytime there's been changes in the project, you would hit this Update eSpec Specs button up here in the corner, and that informs eSpECS that there's changes in the model, and the spec writer has the ability to accept or deny those changes on a section-by-section basis. So they have a green light, red light, yellow light kind of system where green means it's a new section coming in, red means the section is no longer required because something's been deleted, and yellow is there's a revision to the section. We have found there does come a point where, if you do a lot of editing to that section, getting additional updates coming out of the Revit model towards the very end, before the deliverable can be an issue. And so sometimes it's easier just to kind of go back into manual mode and pick up some of those things. But we're kind of still working through some of those processes.
And how about on the master side, when eSPECS updates, or when Master Spec updates their sections on a quarterly basis?
Just this year, I think in January, eSPECS released a add-in to Office that allows you to compare and contrast your Master Spec with the new revised version of Master Spec, and they have tools that help you incorporate the differences between each other and to make those updates. So yeah, that tool's out there, and it's just not part of this presentation.
Sorry for cutting in there, but I think we're just about out of time. So maybe what we can do is, Rob, we can save these questions that have come in, right?
Yes.
I think that idea that you mentioned, Beth, that came in from one of the respondents, I think we've talked a little bit about this, is maybe having a panel maybe after the next presentation, and get you and Brian and next month's presenter, if we're going to get someone else from BSD, and to just sit on a panel, and then we can have these questions and go through them and let people ask other ones.
Sounds good.
Online. So maybe we'll aim for that in the future if you'll come back, Brian.
I definitely will.
Great. I think people will like that because you've done a great job and you've sparked a lot of questions here and a lot of interest. So thank you very much. Beth, did you want to add anything regarding Brian's presentation?
No, I think it was really great, and as we're always asking, if people have things that they're doing that are different and great, these are tools that different firms use differently that we're all trying to learn from each other on. So if someone's doing something fabulous, let us know what it is so we can continue to raise the bar in our industry.
Right, and good point. We're trying to illustrate how to do things, not endorse any one specific approach or one specific piece of software, but give you ideas about how to adapt this in your practice using whatever tools you choose. So that's been the theme of this whole series we've been doing. Well, I think that brings us to the end of our webinar for today then. Again, thanks to Brian, thanks to Beth for helping out and handling the questions. Again, thank you all for joining us today. If you do have any further questions or comments that you want to make, send them to myself or to Rob Holson at CSI, and we'll be happy to get back to you in response.